Hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass code at this side. Welcome to another video which is known as valid BST, right? Validate BST. The problem is simple. You have been given a binary tree and you have to tell me whether this is a BST or not, right? You have to tell me in the form of true or false. For example, the two test cases given to you are 5 connected to 2 on the left and 7 on the right and 2 connected to 6 on the right. Is it a BST, guys? Is it a BST? For those of you who do not know about what a BST is, so let me explain you. BST is a simple binary tree with this property, right? Each node follows node value should be less than value on right subtree. Value on right subtree. Each value on right subtree, right? It should be less than each value on the right subtree. I can also say minimum value. That is also equivalent. Also, should be greater than maximum value on left subtree. Maximum value on left subtree, right? This is the definition of BST. BST is just a binary tree where the left subtree maximum value is less than the node value and the node value is less than the minimum value on the right subtree. So for this example, 5, 2, 7, 6. 5, 2 is less, 7 is less, but 6 is also the part of the left subtree of 5, but 6 is greater than 5, right? 6 is greater than 5 and it is present on the left. So it is not a BST. This is not a BST. But in the case of this one, 5, 2, 4, 3, 7, it is a BST because the following property is getting hold of for the all the nodes, right? So these are the two particular examples. The question is gonna be easy. Okay, so how will you solve it? How will you solve it? Let us take the false case first. 5, 2, 6, 7. 5, 2, 6, 7. Okay, so I said that this is the tree given to you. 5 connected to its 2, connected to 7, connected to 6, right? Obviously, because it is a binary tree, so you will be given root in your hand, right? The input is root, right? Now what you will have to do? Now you know that root can get into any value. Root can get any value from minus infinity to infinity, right? Root can get any value in minus infinity to infinity. But because I said that the left subtree should have a value less than the root value, the maximum value in the left subtree should have a value less than the root value. So what can I say? For these two nodes, for the left subtree of root, the value should go from minus infinity to 4. From minus infinity to 4. Why 4? Because 5 is the value of the root. So it should be coming from 4 because it should be lesser than, right? And all are integers. So just a lesser integer than 5 is 4. That is my approach. That is, I will call the function for root, right? And I will provide the two values to it, minimum and maximum. Minimum and maximum. If my root equals to null, then nothing can be done, just return true. Return true, right? Because null node is always a BST. Null node is always a BST. An empty binary tree is a BST, right? Okay. Second thing is if root data is either greater is either lesser than equals to minimum, is either lesser than minimum, or root data is greater than maximum, that is it is not in the range given to you, then you have to return false. Then you have to return false. Because what is happening, if you see, for the root, it will come at minus infinity infinity. It can get any value from minus infinity to infinity, but as soon as you go to 2, it can have value from minus infinity to 4, right? And because you are going to write, the minimum of write should be greater than 2, so it will be 3 comma 4, 3 comma 4, right? So as soon as 6 is not in the 3 comma 4, it will return false. And because one of the child is returning false, I will return false. And because one of the child is returning false, I will be returning false, right? So what is happening, if root data is lesser than minimum or greater than maximum, return false, right? This is the first case. Second case is, if it is not true, if it is not giving true, then what do you have to do? You say bool left, that is the answer from the left subtree, is equals to same f of root left, but now the range changes. What is the range? Minimum will remain same, but the maximum will be root data minus 1. Root data minus 1. And similarly, bool right is equals to f of root right, and max minimum will be now root data plus 1. Root data plus 1, and maximum will remain same, right? Okay, so if Either root left is null or false, or root right is false. In that case, return false. Otherwise, return true. Return true. Right? Return true. This is a simple case of the validating the BST. This will give you the exact number. What is the time complexity, guys? So I'm actually using our one traversal only. So it is O of n time complexity with O of 1 space. There should be no problem in it. There should be no problem in it. Obviously, there is a recursion stack space of log n that I'm not writing. Okay. Now, I have another approach from you. I have another approach for you. For those of you who solved yesterday's POTD, we derived the property that in order of BST gives me a sorted order. Sorted order. Can we compare from this only? Can we compare from this? What I'm trying to say is, if the tree given to me 5, 2, 6, 7. I hope you all are familiar with the inward traversal. So if I take out the inward traversal of this tree, of this particular tree, it will look something like uh, 2, 6, 5, 7. Right? This is my inward traversal, and you can see that 6 is greater than 2, and it is not sorted. And because it is not sorted, no, that is why it is BST, no. So what you can do, you can create an array of the inward traversal and then tell whether it is sorted or not. But we have already seen the problem of O and O1, right? Why are we seeing the problem of O and O1, right? Because I am able to reduce this O of n into O of 1. How? How? See, how do you compare if an array is sorted or not? So you see this value should be less than this value. This value should be less than this value. This value should be less than this value, right? As soon as any one of the pair returns false, you will return false. That is the condition, right? Now, can I say that if I just have to compare this with this, that is, I have to compare this with the forward, with the successor only. Can I do something like this? Can I store something? Can I store 2 somewhere, and when it comes to 6, I can check for it? Yes, it is a valid approach, right? So what will I do? I'll say I have not started my in order yet. Suppose my node is null. Suppose my node is null. I have pointed a node towards null. Name it as previous, right? I start with the in order. I start with the in order. So let me write down. So in order of root and previous. Now mine, because I'm using previous from the previous approach, I will be sending it by reference. I will be sending it by reference. So again, if root equals to null, I always told that a null node is always a BST, so return true, right? Otherwise, if previous equals to null, or root data is actually greater than previous data, this is the condition for sorted order, right? This is the condition for sorted order, right? In that case, what you will do, you will say, now my new previous is gonna be root. My new previous is gonna be root. Else, if this condition is not satisfied, either the previous is not null or this one, like something that is happening, in that case, return false. Return false, right? But this is not in order, right? This is the case of exploring the root. I have to write something like this here, that bool left equals to in order of root right, left with previous. If left equals to false, that is this called return false, simply return false. You cannot do anything else. You know that if one of the subtree is returning false, then it is also false, because 2 will be returning false to 5, then only 5 will return false, right? Okay, and now after this I will add again the same thing here for bool right, that you have explored the left, then the root, now explore the right. In order of root right with previous, and if right equals to false, return false, right? If right equals to false, return false. If any of the false is not working, this is not working, this is not working, this is not working, then in the answer return true. Return true. That's all. That's all. So what is actually happening is, previously or previous equals to null, I get called for 5. 5 calls for 2. 2 now says I don't have a left side. So what does 2 see? 2 says previous is null, so assign 2 to previous. So previous now contains 2. Previous now contains 2. Right? And now moving on, the call will go to 6. 6 will compare itself with 2. 6 will say, hey, previous node is 2. 2 is good, right? 2 is good. 2 is greater than, or 6 is greater than 2. So I will be changing it to 6 and I will be returning true. And 2 is returning also true. Now 5 comes here. 5 says, hey, my value is less than the node. My value is less than 6. So I cannot return anything. I will just return false. And it will return false. As simple as that. Because you can see 6 comma 5 is the one which is returning false, because 5 is not greater than 6, and that is exactly what happening here. The time complexity is usually as usual O of n, and the space complexity is O of 1, because we are not using an array, we are just storing a pointer to store a node, right? So I hope you are clear with it and you are happy to see the code now. Guys, so here is the coding section, but before starting with the code, it's my sincere request to you to please subscribe to this channel, because it really motivates me and I really need it. Right, now moving on, what will I do? I will just simply say return is BST root with previous. Right, so first assign a previous here. So node star previous is equals to a null node. Right, not is BST, I will say in order. Is BST is already implemented. Now what will I do? I will just implement the in order. Let me change the spelling, correct the spelling. Right, so it is returning a bool type function. So bool in order node star root node star previous. Simple. If root equals to null, return true. Now if then check for left. So bool left is equals to in order for root left with the same previous. Also, I forgot to put an and percentile over the function, because the previous is sent by reference. Previous is sent by reference. That is, it is static type of thing. Now if left equals to false, return false. Right, you don't have to process anything else. Now if previous equals to null, or root data is greater than previous data, in that case your BST is still maintained, so you just change the previous to root. Else, if any of the condition of the above is not following, return false. Return false. Then move to right. So bool right equals to in order of root right with the previous pointer. Again, if right equals to false, return false. Otherwise, return true. Right? This is the whole thing you have to do. Let us try to compile and run it. Hope it will work fine. Should not give any error. It is working fine for the sample test case. Let us try it for the submission test case as well. It is running and taking a lot of time as well. Okay, so you can see it is a 222 day streak. Thank you for watching. Have a nice day. I will meet you tomorrow. Thank you. Have a nice day.